Welcome to Learn Robotics and AI, and in this video I'll be sharing with you the experience of a student who is currently doing his master's in curriculum design. He's from the United States, he's 30 years old, and for the sake of confidentiality I'll be referring to him as Peter Whitman throughout this video. He did his bachelor's in computer science and he is interested in curriculum design roles or developer relation roles for computer vision or machine learning as applied to robotics. He says he has a passion for teaching technology and he seeks to build a technical foundation. When I talked to him, he was motivated and introspective and he wanted to build a career that was meaningful to him and not take up any career that just earns a lot of money. So he was very keen on building a purposeful career profile and he wants to seek mastery and gain a deeper level of understanding in one specific subdomain or a domain at the intersection of certain subdomains of his interest. And he currently has some basic foundational understanding of Python. He has taken up some courses online to really understand Python, and he is also gaining more knowledge in Python by learning through courses and building projects. He doesn't know C, C++, or ROS. He has worked at a software company before as a software engineer, and he also worked in a teaching position where he was involved in training kids on basic programming related tasks, and that is where he found his passion. He wants to work at the intersection of teaching and technology, and specifically CV or ML as applied to robotics. So this is what he wants to explore, and he is interested in ML or CV for robotics applications, specifically in particular agricultural or harvesting robots, and also finds climate change as a meaningful cause that he can explore machine learning or robotics in. He is not inclined towards research and he is more interested in developing a teaching profile in the engineering domain, and he seeks to gain a technical understanding and build a strong engineering foundation so that he can then uh, take up teaching roles. He cannot pursue a further master's in AI or robotics because he's already pursuing a master's and he cannot afford to pursue a further master's after that. He has no time constraints and he cannot relocate to another location due to his personal constraints, and so is keen to remote positions but also positions within his city. He can dedicate 2 hours every single day and 4 hours on the weekends. So, looking at his aspirations, he's interested in curriculum design roles or developer relations roles for CV or ML applied to robotics. He has a passion for teaching and he seeks to build a technical foundation. And this is how the learning framework would look like for him. So, it would consist of 4 phases. The first phase is software engineering foundation, just gaining a foundational understanding of programming and Python in particular, and then after that gaining some fundamental understanding of machine learning, building a foundation in machine learning, and then building a robotics foundation, and then creating tutorials or mini courses or guides in the last phase, because he is looking to explore teaching positions in particular. So one important concept, since he is looking to build a career that is meaningful and purposeful, is that of finding your niche or finding your ikigai, are which point to the same concept essentially, and those would lie at the intersection of these 4 blocks: what you love doing, what you can be paid for, what the world needs, and what you're good at. So for that, one needs to identify their strengths and values and really understand their interests, what kind of projects you're interested in, what kind of topics you're interested in, what kind of technology stack do you really like working with, and what sort of applications would be really impactful to you. So for example, Peter mentioned that climate change on agriculture would be impactful to him, teaching would be impactful to him, and we would be looking at how I would be building his curriculum in this video. Also, what you can be paid for. Essentially, there has to be job opportunities for your interests and your strengths. So for Peter, he knows that his strengths are in teaching, technology, and teamwork and collaboration, and essentially programming, which he also seeks to gain more knowledge and understanding in. So these are his strengths, and these are the things that he knows he is good at, and he is willing to spend a lot of time really also gaining more expertise in these domains. And the topics that he's interested in is, as I mentioned, machine learning and computer vision, specifically for robotics applications. And note that this is a preliminary list, and only one can only accurately define their own strengths, values, and interests when they really spend some time and introspect and really decide it on their own. So if you are following this video and really defining your own curriculum, you should pause the video and maybe think about what kind of things you're really interested in, what are your values and strengths, and I'll be talking about how you can do that in the coming slides. So here's a list of some of the values that you can look at and really find the top 3 values that would be beneficial to you, that you find really meaningful. Is learning most important to you, or is creativity and originality most important to you? Is independence in work most important to you, or is it teamwork and collaboration that is more important to? Is Do you value stability, efficiency, growth? What is it that you value? So you should identify your values, you should identify your strengths, and that would include, essentially, that could be teaching, that could be teamwork, that could be systems thinking, lateral thinking, programming from scratch, and a lot of different things. And these are some things that one can do by multiple ways. One is essentially by really introspecting and looking at the kind of projects that you might have done in the past, and that you know you're good at, or you can take up more projects, and while you are following this curriculum you can really essentially figure out what your strengths are. Essentially understanding your interests. So for Peter, his interests are very clear. He is interested in machine learning or computer vision for robotics, although he still needs to figure out what specifically his subdomain of interest is. So job opportunities that would be relevant for Peter are instructional designer, robotic software engineer positions, machine learning engineer positions, or computer vision engineer positions. Although he's primarily interested in teaching positions, and that is why the whole curriculum would be primarily focused on that, but he gets to explore other subdomains, and he can then decide which of these other positions would be really meaningful to him. What does he find impactful? Education, teaching, and upskilling others, agriculture, and climate change. So finding your niche, one quick point, and if you want to have a detailed look at how to define your niche, I have covered all of these concepts: how to define your values, identifying your strengths, in my video titled The Ultimate Robotics Career Guide. So you can go ahead and watch that video after watching this video if you really are looking for a very detailed guide specific to building a career in the vast domain, in any of the domains of robotics or AI. So essentially, one really critical factor in defining your niche, or defining or finding work that is meaningful, is finding something that is at the intersection of skills and challenge. So maybe for Peter, teaching is something that brings him into a flow state. So this is something that he finds meaningful. Maybe once he starts building programming projects, he can then realize whether computer vision projects or machine learning projects really bring him into flow state. And that is a really accurate way of really finding work that is meaningful, because if you do not enjoy some work, you would not really find that meaningful, even if that work might have significant impact. So finding work you love doing is also very critical. So here's how the yearly plan looks like for him. So following the learning framework of 4 phases, the first quarter would essentially be focused on building a programming foundation, and after that, the second quarter would cover phase two, which is to build a machine learning foundation, and phase three would allow him to build a robotics foundation, and phase three would essentially allow him to explore creation of tutorials, mini courses, and guides, and really exploring his teaching passions in the domains of robotics, CV, or machine learning. And within the first quarter, essentially the first month would be spent on just learning Python fundamentals, essentially continuing with what he has been doing by taking up courses online and really learning Python and understanding functions, arrays, all the basic programming concepts. And then the next 2 months would be spent in building a programming project of his interest. So within the first quarter, the goal would be to just build one basic programming project. And after that, the goal would be to learn TensorFlow and OpenCV, and that can be learned within a month if you take up a crash course, or if you take up a course by deeplearning.ai or fast.ai, any of the courses that are existing online. There's a lot of tutorials also on OpenCV, so these things can be learned within a month. Especially spending 2 hours on the weekdays and 4 hours on the weekends, that would be more than enough to learn the foundations. And then the next 2 months would be again spent in building a machine learning project. And the third quarter would essentially be dedicated to robotics, and the first month of the third quarter would be dedicated to learning ROS fundamentals. And there's a lot of resources that one can refer to in order to learn ROS. I've created a video titled "The Most Comprehensive List of ROS 2 Resources for Beginners," so you can go ahead and check that as well if you are also exploring ROS as part of your curriculum. And then the next 2 months are again in building a robotics project. So you can see that by the end of the first 3 quarters, Peter gets to build a programming project, he gets to build a machine learning project, and he gets to build a robotics project. So one foundational project and two specific projects in the domains of robotics and AI. And then the last quarter would essentially be dedicated to creating tutorials on the Python project that Peter built, and creating a tutorial on machine learning project, and also a tutorial on the project that he created. So essentially creating guides or mini courses or tutorials on all the projects that he created, and really explore what is his niche. Does he really enjoy teaching more machine learning related projects or concepts, or does he enjoy more working with ROS and creating ROS tutorials, ROS educational materials, and so on? So that is how the yearly plan is structured. So looking at details, how can Peter learn the fundamentals of Python? Well, this can be easily learned by doing a crash course. Building a programming project will essentially give the technical foundation needed to start learning other specialized domains such as machine learning and computer vision, and that can be done by first creating a list of fundamental programming projects and choosing one project based on your interest, and creating a project plan. And once that plan is done, you can dedicate your time on really building the project, and refer to online resources such as Stack Overflow, or just do a quick Google search. You'd be able to find a lot of resources where you can get answers to your problems, to your debugging related issues. So I think no further elaboration needs to be done on this. This is a fact that can be easily this is a point that can be easily resolved by a quick Google search. So as a beginner, stick with Python, as that is easy to begin with, and it's also widely used for machine learning and data science. And do not spend too much time over analyzing and finding the perfect topic. And this is a general remark that I would like to give, is that as a beginner, you probably spend too much time over analyzing and really trying to find the perfect project, the perfect plan. There is no perfect project and plan. You just have to get started with doing things. Just choose any programming project that you find interesting, and just start doing it. And if you don't like it, you can drop that project and do some other project that you find interesting. But if you don't start doing it, you would never really be able to understand what kind of projects you enjoy working with. So the duration of the project should be 1 to 2 months, and not 3 or 4 months, because we want to explore specialized fields such as machine learning and robotics later as well. So quarter 2 is dedicated to learning TensorFlow and OpenCV, and essentially building a machine learning project in the computer vision space. And for that, you can take up a course by deeplearning.ai or fast.ai, or watch a crash course or tutorial series on YouTube. Free Code Camp is also a very reliable resource on YouTube. It's a YouTube channel that you can refer to learn the fundamentals of TensorFlow and also OpenCV, or even other robotics concepts. And after you have learned TensorFlow and OpenCV, after you have a foundational understanding of these two libraries, you should then create a list of projects. Again, choose a project based on your interests, prepare a plan, build a project, and you can look up for resources online if you realize that, hey, I do not understand some of the machine learning concepts, or if you get stuck in a debugging programming related issue. And the goal is to build a machine learning project in the computer vision domain using TensorFlow and OpenCV in order to get exposure to image processing, computer vision, and machine learning. And the third quarter is to essentially learn ROS fundamentals. As mentioned, you can watch my video titled The Complete List of ROS2 Resources for Beginners. And that would essentially give you a list of all sorts of ROS2 resources, tutorials, YouTube playlist, free and paid courses, everything you need to know about ROS2. Just stick with any resource that you resonate with and just start building a project, and build a mobile robot, drone, or wheel navigation related project, as that would be the most applicable to the agricultural sector. Another point about phase 2 essentially is that in phase 2 you can explore a lot of machine learning or computer vision projects specifically dealing with climate change. So it doesn't have to be computer vision projects, but it has to be applying machine learning to climate change, so you can really explore your interest. So the phase 2 has to be dedicated towards exploring the climate change application, and phase 3 has to be dedicated towards learning and exploring agricultural robotics domain. So this way you can get an exposure to robotic software engineering and also machine learning, and also explore what domains do you really find meaningful, agricultural robotics or climate change. And in the fourth quarter you can of course get to experience teaching, and you can either create a blog post explaining the project, you can create a video tutorial, you can make a Jupyter notebook. And the goal is to really find out what is your ideal medium in which you want to communicate, in which you want to create instructional courses. Is it written content? Would you be making Jupyter notebooks? Is it programming that you is it creating Jupyter notebooks? Is it programming that you enjoy doing most, as you did in the projects? Or is it creating video content or conducting workshops? Or is it the speaking skill that you find most enjoyable? So even within teaching you have to really identify what specifically is your ideal mode of communication, and really double down on that, because it's also important to really figure out which mode of expression you really find most meaningful. Is it conducting lectures? Is it making tutorials using Jupyter Notebook? Is it creating video content? And that is something you can explore and decide in each of these three tutorials or mini guides or courses. Okay, so enough talking about the yearly goals. Now we would split these monthly goals that we set into 4 sub goals for each week, and we'll try to consistently spend a minimum of 2 hours daily and 4 hours on the weekends. This is essentially something that everyone can dedicate time to. For some people maybe 2 hours would not be feasible, so you can still dedicate 1 hour or more hours on the 1 hour on the weekdays or more hours on the weekends. And the way to really commit to spending these hours is by blocking 2 hours on the weekdays first thing in the morning if you can, or at the end of the day, and then block 4 hours on the weekends and put the hours on the calendar and really stick with the schedule. And if you're struggling with accountability, you can use focus mate to stay accountable, which is something that I also personally use sometimes. So after these quarters, you should really ask yourself, what is it that you enjoy doing most? After quarter one, you have already built a programming related projects, then you can really try to figure out, do I enjoy programming? And even if you do not enjoy programming, you can still explore teaching. Maybe it is the theoretical concepts in machine learning, computer vision, or robotics that you would like explaining more. This is also something that you can explore as part of building uh, teaching tutorials or teaching videos or teaching workshops or notebooks. So do you really enjoy programming? So this is the preliminary question that you need to answer for yourself. And in quarter two, you have to ask, do I enjoy building machine learning projects? Because you might enjoy programming in general, but maybe the TensorFlow framework or defining neural networks and really working with machine learning projects is not really meaningful to you, because it's playing a lot with data, and not everyone finds that interesting. And you also should be asking, will applying machine learning projects to climate change be meaningful to you? Would it be meaningful? uh, is it an application that I should dedicate a lot of time to or not? And after third quarter, once you have built a ROS related projects, you should ask, do I enjoy working with ROS? Do I enjoy working on robotics related projects? Will programming agricultural robots really be meaningful to you? Because currently you think that it is something that you would enjoy doing, but only after you building a mini project or exploring the field, you'd be able to really understand, hey, is this something that I really like doing or not? And after fourth quarter, you have to really choose between whether you want to go fully into the engineering route or the teaching route. You still have the possibility to not go towards the teaching or curriculum design route, and directly going towards programming for agricultural robots or machine learning engineering roles. And you have to really decide, hey, what is it that I can do that would have a bigger impact? Is it building engineering projects or is it teaching? What is it that I like doing more? And another thing that is important to do is, after answering these questions after each quarter, one should also answer the following questions after all of these things have been done. You should really try to identify for yourself, what are my top three values, what are my top three strengths, what impact would be the most meaningful to me, taking my values, strengths, and interest into account. What domain would I like to master? What is it that I could spend a lot of time on without getting bored, or even if it is tiring, I would still like to spend time learning that and mastering that skill. Is it teaching that you would like to master? Is it teaching machine learning that you would like to master? Is it teaching ROS that you would like to master? Is it building robotic software engineering projects for agriculture that you would really like to gain a deep level of expertise in? Or is it climate change, machine learning for climate change, that you're really passionate about and you are willing to dedicate a lot of time towards? And again, the same question that you should be answering and asking yourself again, what activity brings me into a flow state? And now I'll come to a framework that you can really choose, you can really follow in order to define and find meaningful work. And that is to define a life purpose statement for yourself. You do not really need to define a statement, but you need to find work that is meaningful. And in order to do that, this is the best framework that I have found so far. So what do we mean by life purpose? Life purpose is essentially identifying your top strengths and using that top strength, what is the biggest impact that you can have on this world. um, so what is your top strength? Is it teaching, is it programming, is it project management? And for Peter, it could be it could still be multiple things, and you have to really identify which is my top strength. Is it teaching? And not just strength, actually, what is something that I enjoy doing the most? So it boils down to the same ikigai diagram of really finding an intersection of all of the different things. So what is my top strength? Is it teaching technical concepts? Is it programming? Is it building machine learning projects? Is it managing machine learning projects? What is it that I know that I'm really good at, or that if I know if I spend 10,000 hours doing, I would really enjoy spending those 10,000 hours, and I would really gain that expertise. And what is it that I'm willing to spend so much time towards? What impact do I want to have on the world? For Peter, is it upskilling students? Essentially, is it teaching? Is it agricultural robots? Is it climate change? If you are a viewer, for you it could be something else, so you can sit down and brainstorm if you are also looking to build a meaningful career. And what is your ideal medium? Is it speaking, programming, and writing? And I've talked about this in one of the previous slides. And you also have to define your niche. Is it machine learning, robotics, or computer vision? Because even if it is teaching, you can become a generalist teacher, or you can focus down on one specific subdomain. So here are some possible life purpose statements that you can look for, use as reference to define your own life purpose statement. So one of these could be to leverage my expertise in teaching technology to bridge the knowledge gap among the youth, ultimately equipping them with essential skills for a better future. So essentially, the structure of the life purpose statement is such that what are my top strengths and how I can have an impact on this world, and in what way would that be impactful. Another statement is to design and implement machine learning pipelines that will actively combat climate change. How specifically? By optimizing renewable energy usage, reducing carbon emissions, and promoting sustainable practices. And this can be designed individually based on uh, your own interests and what you find meaningful, to create autonomous robotic systems that will actively um, combat climate change. Okay, so again, here the impact statement is combating climate change, but essentially it would be related to agricultural, to make an impact in improving the yield of agriculture or harvesting. So this is a typo that I have here. Essentially, for the third statement, the impact would be towards agriculture, and you can really define those statements based on what is really interesting to you, what is really impactful to you. And this is something that you can only define really accurately once you have done all these projects, once you have really had that exposure to all different applications and all the different modes of teaching, all the different modes of really building projects and so on, all the different ideas that we shared in the plan. So now I'll give you a list of projects that are specifically that would be specifically useful to Peter. So one is, for example, automated weed detection and removal, and the goal of the project would be to simulate a robotic platform that uses machine vision to detect weed and simulate their removal in a virtual agricultural field. So all of the projects that I share can be done in a simulation, and you can even reduce the scope of the projects. The goal is not to build a very detailed technical professional project, because you're still exploring and trying to understand what domains you're really interested in. The algorithms that you would expect to work with in this project is object detection for weed identification, you can look at YOLO, SSD, and some other object detection models. Path planning algorithms, you can you work with ROS and OpenCV. Move it package for motion planning. Tools are essentially ROS and Gazebo for simulation. Another project is precision irrigation system and other agriculture related projects to simulate a robotic irrigation system that measures soil moisture levels and irrigates specific zones accordingly. And you can expect to use PID control for water dispensing, decision trees for soil moisture classification, ROS, scikit-learn, Python control library are the packages that you would expect to work with. Gazebo and simulated soil moisture sensors in ROS. So the details of these projects can be easily found online, and you can also choose projects for which there is better documentation and there is more support. So that's why I'm giving five different projects, and you just have to choose essentially one. And these projects are essentially for the third quarter, where you're exploring robotic software engineering positions for agriculture. Crop health monitoring is another project where you can develop a simulation where a drone like robot uses multispectral imaging to assess the health of crops and generate a health report. You'd work with machine learning, image segmentation, anomaly detection, ROS, OpenCV, so very interdisciplinary project using Gazebo and ROS. And of course, you do not need to have access to drone. Try to work in a simulation environment as much as possible, or reduce the scope if the projects that I mentioned seem too complicated. And the next one is then autonomous harvesting robot. And the goal is to simulate a robot that identifies ripe fruits using computer vision and plans a path to collect them without damaging the crops. Algorithms that you can use are object detection and path planning algorithms such as RRT. ROS, OpenCV, and MoveIt are the primary package essentially in most of the projects that I'm sharing here. And the last project that you can consider for a robotic software uh, robotic software engineering specific to agricultural robotics role is to develop a simulation where a robotic platform uniformly distributes fertilizers based on crop growth stages, identifying using computer vision. You work with basic image classification and PID controller for fertilizer dispensing, and essentially you work with ROS and TensorFlow here. So, what are some climate change related projects where you can apply machine learning? Um, One is carbon footprint prediction, to develop a simulation that predicts the carbon footprint of a certain area based on various parameters such as energy consumption, vehicle usage, and industrial activity. Regression analysis, general machine learning algorithms can be used here. And you would have to create a custom simulation environment, and you can reduce the scope of this project as well, and really focus on um, essentially machine learning part of it if you're specifically looking to explore that. For climate pattern recognition, one project could be to analyze large climate data sets to detect abnormal weather patterns. Is a common project for which you can also find a lot of tutorials or resources, especially medium articles is something that you can look at. And then you would be using time series analysis and anomaly detection specifically, and you would be working with pandas, matplotlib, and TensorFlow. Another project is that you would find interesting is to develop a simulation that optimizes energy consumption in a smart grid to reduce CO2 emissions, and you can explore reinforcement learning, which is another subcategory of machine learning. You can work with TensorFlow and OpenAI Gym. Air quality prediction, you can use historical air quality data to predict future air pollution levels by helping in taking preventive to preventing measures, and essentially it's time series forecasting related project that you can consider. And the last project for you is to simulate a system that analyzes satellite images to detect and predict deforestation activities. You can use image segmentation and object detection using TensorFlow and Python and OpenCV. And essentially, the purpose of this list of projects is not to directly follow these problem statements, but essentially to give you a sort of direction on what are the things that you can explore within your interests. And essentially, you can find more specific problem descriptions online. So just do a quick search on the projects that you find interesting and choose one of these projects that you find really interesting. So one machine learning for climate change related project, and one robotic software engineering for agriculture related project. So now Peter also had a lot of queries, and I'll try to answer these in this section. I tend to force myself to get expertise faster and rush myself and burn myself out. How do I consistently make progress towards my goals? Well, a tendency to overwork and burnout tends to arise from not having previous experience and not having faith in one's ability and not planning long term. So, if you have clear goals for the whole year and a realistic plan for each quarter and month, the likelihood that you would stick with it is higher. And the best way to do that is to make consistent progress towards your learning goals by creating a plan for each week, evaluating every single week, and scheduling focus blocks for every single day and following the schedule. So once you have a system, this problem should no longer be there. And you can watch the video titled The Complete Robotics Productivity Guide for beginners, and that covers these ideas in a lot more detail. And I've also shared a lot of tools there, so that would be something that you can find beneficial. Another productivity related question is, how do I structure my day to be more productive? Since you're enrolled in a full-time master's program, of course that is something that you would have to prioritize, but you can still schedule 2 hour focus block sessions every single day. Maybe you can do it first thing in the morning so that you can really get done with it and then focus on your master's program, your curriculum and assignments and other sorts of things that you might have to do. And another important point that I would like to point here is that it is normal to not stick with 50% of the tasks on the plan. The purpose of the plan is to simply structure your days so that you have a direction and you're not really scattered, right? And you do not have to decide what to do next, because if you do not have a plan, you would say, hey, I could do this, I could do that. But if you have a clear plan, if you have things on your calendar, you do not have to decide too much and waste too much of your willpower in making a lot of decisions. And this is also the reason why a lot of CEOs like Steve Jobs and Mark Zuckerberg wear the same t-shirt. That is, of course, taking things to another extreme, but essentially it's the same concept of eliminating as many decisions as you can so that you can really focus on mastering your skills and really making a contribution uh, by means of your work. So while you do not have to go to that extent, having a plan and knowing when to do what would be significantly beneficial in making you more productive. How much time should one invest on MOOCs? MOOCs are useful if you actively consume them, and then you can use it to as effectively learn the fundamentals of a topic, but they are not sufficient in and of themselves. If you rely blindly on MOOCs and passively consume MOOCs without taking action, they are useless. So prioritize building projects, and you can gain a foundational understanding of theoretical concepts by taking up MOOCs. And this is also the reason why I have created the plan in such a way that the first month of each quarter is dedicated to really understanding the basics, getting familiar with the tools, the theoretical concepts, and then the next 2 months are dedicated to building projects, because projects are the most important. Which deep learning framework is commonly used in robotics with computer vision enabled? Is PyTorch more widely adopted than TensorFlow? Essentially, long story short, PyTorch is used more in research and TensorFlow is more widely used in production, and it has better production related capabilities and functions. So that is something that you can find, you would find more beneficial, essentially because you are more interested in engineering related roles. So you can pause the video and read the details. This is essentially from a LinkedIn post that I created where I really compared TensorFlow and PyTorch. But to summarize, TensorFlow would be more preferred for beginners because it is easier to learn. And for your specific scenario, as you're interested in engineering and implementation, TensorFlow is a better alternative as it is most used in production. PyTorch is getting more popular these days, and eventually it might even replace TensorFlow in the future. Nobody can say that, but you can stick with TensorFlow and really explore, and eventually switching frameworks later is also not that big of a deal. What strategies do you recommend for someone like me who wants to work remotely in this field of robotics and AI? How can I be so good that they don't ignore me for being a remote candidate? Working remotely is not a disadvantage at all, and a lot of companies, as you know, have remote roles. Even bigger companies like Google and Meta allow remote working positions and allow you to work remotely. In software, the way is simple. If you have good skills, if you spend a lot of time building programming projects and learning the fundamentals of programming, then essentially you would never run out of opportunities. You would have a lot of opportunities. You can build a strong portfolio of projects and make sure that the projects that you build are industry specific. And in order to ensure that, before learning a tool or a skill, make sure to look at the job profiles of companies that you're really interested in and look at the requirements, and look at the kind of skills and the tools that they require. So, for example, here you can see that they require experience with C++ or Python, experience with deep learning techniques in NLP and computer vision, experience working with scikit-learn, SciPy, Pandas, NumPy, TensorFlow, PyTorch, MXNet, essentially the standard machine learning libraries and frameworks. Experience with Git, issue tracking, CI/CD, and modern software engineering. I haven't talked about essentially learning Git and Ubuntu in as part of this curriculum, but this is essentially something that you can look up in my video titled comprehend the top robotics skills in 2023, and there I have talked about all the skills that you need to know as a beginner. And essentially you can focus on Python and building a foundation with that, but Git would also be a very important skill, and that is why having a look at the profiles, job descriptions of profiles of companies is very handy. What level of data structures and algorithms do I need to master to apply for the robotic software role? You need to understand the fundamentals, which you can easily find in a standard data structures and algorithm textbook or course. There are these standard topics and algorithms, and I have listed some here. Arrays and strings, linked lists, stacks, queues, trees and graphs. Essentially, you can. A lot of people learn these in school, but also in their bachelors in computer science. So essentially, brush up these fundamental topics. Those should be sufficient. You can look up a standard data structure and algorithm textbook. I think it shouldn't be that hard to find. Some algorithms are searching, sorting, recursion, and backtracking algorithms. Dynamic programming, graph algorithms, Dijkstra's, A star, and some other optimization algorithms such as simulated annealing that you can look at. You can pause the video and really take note of these concepts and algorithms if you are looking to explore these concepts by yourself. But I would recommend you to essentially take up a course or watch a YouTube playlist and essentially follow it end to end. And that would be enough to really gain a foundational understanding. What niche fields within robotics software development or computer vision do most people overlook? Which skills are always in demand? Well, this is a difficult question to answer. What niche fields do most people overlook? There's a lot of different subdomains, and here are some lesser known fields. For example, swarm robotics, dealing with collaborative robotics and multimodal sensing, using a variety of different sensors for perception. But as a beginner, probably you wouldn't have access to these. Robotic rehabilitation, these are a lot of there are a lot of niche fields, and if you are looking for some niche fields that might be overlooked, a lot of research institutes have their research advertised, and you can go ahead and look that, but you're probably not interested in research, so I didn't give a more detailed list here. So there are some other niche domains you can explore. You do not need to overanalyze and research all fields that exist in robotics. Essentially, I am trying to emphasize the importance of taking action. You have an yearly plan, yearly, monthly, weekly and daily plan. Just try to stick with it and not get distracted by a lot of other interesting projects that you might encounter while you are learning. So essentially, stick with it, build projects, and then move on and try to find more projects that you're interested in. And only after you build projects would you be able to understand which what domains you are interested in, and then you can go deeper and explore these niche domains. For instance, skills in demand. What are skills that are always in demand? Of course, C++, Python, and ROS. And by the way, C++ is probably more important for robotics. But since you want to explore and get a sense of the different domains, essentially starting with Python would be a better thing to do for your particular case. You also need algorithm development, general control algorithms, and path planning, and you can gain those skills just by doing the projects that I have highlighted in the curriculum. Cybersecurity, this is another skill that is in demand. You can focus on security related to robotics, and specializations are essentially perception, motion planning, manipulation, and grasping. There's a lot of other subdomains, but you would be able to identify those subdomains once you take up some projects related to agriculture, and the subdomains would be specific. The subdomains for each application might be slightly different, although navigation, motion planning, and manipulation and grasping are pretty much standard in a lot of different robotics applications. Okay, so the next question is, how should I practice my learning to develop mastery in your devised outline? Okay, once you have your life purpose statement defined and your niche clearly defined, you can take up projects on of increasing difficulty and complexity to gain more experience. And here I'm linking an article which I've also shared previously in some of my LinkedIn posts called 10 Steps to Mastering Anything, and that is essentially following a progressive mastery framework by Brendan Burchard. And you can essentially read this article and follow a step-by-step framework to gain mastery. And long story short, to gain mastery, you have to spend a lot of hours and essentially try to build up projects of increasing difficulty. Try to spend 10,000 hours within the next 6 to 7 years, and you would be able to gain mastery. What are some great USA based companies that are at the intersection of computer vision and robotics? NVIDIA, Boston Dynamics, iRobot, Waymo, OpenAI, Oculus VR. There's a lot of different companies that work at the intersection of computer vision and robotics, and these are some companies that build a lot of interesting applications. So this is another interesting question. If you could go back in time, how would you prepare yourself for robotics or computer vision roles? Well, essentially, when I started out, um, when I was learning ROS and when I was learning TensorFlow, I relied too much on passively consuming tutorials and watching MOOCs, which did play a role, but it wasn't really that effective at all, and it wasn't efficient at all. it is also not engaging, and I've started to lose interest because it was just passive learning essentially does not work that well for me. Although some of the MOOCs had interesting explanations, especially the ones by Andrew Ng by deeplearning.ai, but it is not sufficient to really gain practical skills, and it is only after building projects and adopting a problem focused approach did I really start enjoying these things more, and did I start understanding things deeply. So follow a problem focused approach, define a problem you're passionate about, and then build projects and consume theory in order to build the project, and not the other way around. MOOCs essentially prioritize most of the time on theory followed by a little activity or maybe a small project at the end. But you should essentially take a project first and then dig deeper into it and try to really build it. And once you get stuck, should you then look up basic concepts that you do not know, and that is a more engaging and resourceful way to learn. So not following a tools focused approach and a problems focused approach, this is essentially also something that uh, Sebastian Castro has mentioned on my YouTube podcast. You can look up Boston Dynamics there and you'd be able to find video by Sebastian a video of me interviewing Sebastian Castro where he talks about these things. So this would also be very critical. Some bonus questions are how do you gauge the difficulty level of a project, and I've covered these in a lot of different other videos, so I wouldn't go in too much detail here. Essentially focus on finding an optimal balance between skills and challenge. What tools are used in the industry? TensorFlow or PyTorch for machine learning, OpenCV for computer vision, ROS for robotic software engineering, Gazebo for simulation. Before learning a tool, make sure you look at the job profiles. I've already mentioned this. Another important point is how should one apply to startups? So this is a question that somebody else asked me, but it's also relevant to Peter's position. Uh, so I also included this. So make a list of companies in your niche from LinkedIn and job portals. Browse the official website of the companies, make a list of the skills that are required, and build projects using those required skills and create a portfolio of projects and then apply, and feel free to do an unsolicited application. Lastly, watch my video titled The Complete List of ROS2 Resources, and you can start gaining a foundational understanding of ROS and start building up projects. Okay, that is it. I hope this video was beneficial. If it was, make sure to share your experience or share your views in the comments below, and feel free to ask any questions in the comments. I make sure to answer all the comments or all the questions that you would ask in the comments below. And if this is beneficial to you, make sure to also share it with a friend of yours who might find this valuable.